Hi everyone, my name is William Mortman. Today I'm going to be presenting to you a little bit about how networks send data, what a packet is and the parts of it. I'm going to be talking about how networks can be laid out and how to try to prevent your information being stolen off of your network. All right, before I start, I just wanted to put a little disclaimer out there. I'm not a security professional of any kind. Um, I'm creating this video just for educational purposes, based on individual research that I've done. I'm creating this for my ICS 382 class. Um, I'm not responsible for any damage or misinformation that may come from this video. Thank you. All right, so first topic today is going to be on how information travels on a network. When machines are communicating now, they split information up into little clusters known as packets. These packets keep the information organized and together, and prevent data from being lost. This allows for multiple machines to take turns on the network, instead of trying to rather stream the data all at once and create a jumbled mess. All right, so the first part of a packet is the header. Um, Normally included in the header, it specifies the length of the packet, as well as the synchronization, which helps the packet match up with the network, as far as timing goes. The packet number, so if there's a large message that requires multiple packets, this helps the receiver put the packets in order to put together the message on the other end. Um, there's a protocol that's included in there, so if it's like an email versus a different kind of message, different kind of data being sent over, it can specify that in the packet, as well as the destination of where the packet's going to go, as well as the originating address of the packet from where it came from. The body of the packet is the whole point of the message. It's the meat of the sandwich, if you want to call it that. It's the actual data of the packet. Certain protocols require packets to be a certain length, so the body can be padded up in order to um, hit that threshold. If a message is too big to fit in one packet or fit into the amount that you're trying to send it in, it'll be broken up into more pieces until each piece is small enough to fit inside of those packets. The footer is the third major part of the packet. It contains CRC, which stands for cyclic redundancy check. Well, that's a doozy. CRC basically is used to determine if any data has been lost when the packet's being transmitted across the network. Um, it adds up all the ones in the packet and comes out with a sum value, and then includes that in the footer. And then when the recipient gets the message, it can look and count up all of those ones and see if the value that they got matches what they should have got. If the value is different, if it's less somehow, they can ask for the packet to be sent again. All right, so next I'm going to cover a few different types of packets that are used. The first is UDP, um, which is kind of a basic level packet. It's pretty unreliable. The only thing you can really bet on with a UDP packet is that it's sent. There's not a protocol for uh, to tell if it's been received or if it got there in one piece. And then there's also raw, which is similar. There's a few differences though. A UDP protocol field has a fixed value where raw sockets can bind to any protocol number. UDP packets have protocol header. Raw packets do not. Raw data, when read, includes the IP header, but UDP data does not include IP or UDP headers. Raw input packets are delivered to all sockets of the same protocol type and IP addresses, where UDP packets are delivered to only one connected or listener socket, matching IP and port addresses. So they're similar, but there's a few protocol differences between the two types of packets. I also have a few more. TCP, which is the one that I had heard about before taking this class. It's the most, as far as I can tell, the most reliable major type of packet out there. When data is sent, it's sent to the destination address, and it's pretty much guaranteed that the remote host will get the data. If not, it'll ask for it again. And then you have ICMP, which is used to send control and error information between hosts, and GMP, which has to do with multicast router information, which was kind of complicated. All right. So after we talk about packets, the next thing to talk about is monitoring a network. Even though there's different topologies of networks, each is laid out differently based on the machines and what's there. You can use network monitoring software such as Wireshark to track the kind of traffic on your network and to see which machines are communicating with which, track specific packets as well as volume and that sort of thing. This can be useful if there's issues with lost data or possible other issues with the data being sent on the network. So the first, most basic level of network we're going to look at is a point-to-point network, which it just involves 2 points communicating to each other. So, I mean, at a basic level, like a tin can phone where there's a point A and a point B, and the communication all takes place across that line. The the next level of network we're going to look at is called a bus. The example that I got out of the textbook was the old phones that farmers used to use, when there'd be one central line and each house would only pick up if their ring hit the line. And so computers work the same way. In a bus, they're only listening for messages addressed to them. Otherwise, they won't try to intercept the message. Um, yeah. Um, a star is another type of network. As you can see here, each of the outer spokes or individual computers is connected to a central hub. Um, so the computers don't communicate to each other necessarily, but they do communicate through the central area. That could be a computer or a router or network switch. Um, and it's a little bit more easy to set up. It's a very basic system. Um, but if something happens to the host, the whole network goes down because that's where all the communication goes through. Um, and then next we have the network topography for mesh. And so with a mesh, each node is connected to each other node. And so there's lots of different lines of communication. So communication is very quick and very efficient. The issue with a mesh is that the the different when you add a point, the amount of connections to all the other points increases by uh, quite a bit, because each node has to connect to that node again. So it can be kind of tedious to have a direct mesh. Um, you can have a like an indirect mesh with computers connecting to internet service providers, and then those connecting to other major areas, which is a little bit more how the traditional internet is set up. Okay, so we've done all this talking about network layout and what a packet is, and how information moves through the network in a packet. Now we have to talk about what packet sniffing is. Um, so packet sniffing is it's a negative term for network monitoring. Traditionally, a packet sniffing is used when someone who doesn't have authorized access to a network is taking information from it. Um, but it doesn't have to be that way. It just is the normal negative connotation. Um, these special types of software are able to take the data that's being transmitted and turn it into something that people can see and understand. And this allows the person with access to the network to listen into the conversation and to interpret the data that's being transmitted, as well as other information about the network. So one of the programs that we used to help monitor networks in this class through our labs was Wireshark. Um, I messed around with it a little bit on my own, and I got some screenshots that I'll show in a minute. But Wireshark is nice because it's a free software that anyone can use. It's able to capture data from the wire from a live network, or it can analyze things if you've already captured the packets. But so you can set it up to run even just on your home system, and you can see all of the communications that are happening, which I thought was very very interesting. It can also interpret data on different kinds of networks, like Ethernet, IEEE, 802.11, PPP, and loopback. Um, it's got a handy GUI that you can use to look at all the captured network data. There's also a terminal utility as well. There's also lots of ways to filter data as it's being captured, as well as data that's already been captured. Um, to look at different graphs and charts and statistics based on the information that you've recovered from the program. All right, so this first picture, I just I, I s- I installed Wireshark and I set it up on my computer. This one right here that I'm doing the project on, and I just told it to capture, and I did blank out the the IP addresses because I wasn't sure what was sensitive or not, and I didn't want this being on the internet if there were bad things there. But long story short, I I set this up and let it run and let it capture for a little while, and I decided to take a picture of what I found. And I'm able to see different communications with acknowledgments here, as well as uh, an IP address that's trying to be freed up by the router, which I thought was interesting. And there's different kinds of packets being sent here, mostly TCPs, but there's an SSDP here and an ARP there. Um, it was just very interesting to see and see how much traffic was just happening on my home network. It was very, very interesting. I can only imagine how much information's on a large company. All right, so after I looked at the live capture, I decided to apply a filter. And so you can see here up in the top, there's a this is before I applied the filter. So there's an SSL here, there's a TLS there, another SSL, and then I applied the filter of TCP. So I only wanted it to tell me where when a TCP packet came through. And so then from this dark gray down, and it goes out of the capture window. But I was isolating just the TCP packets that I wanted to see, which I thought was very interesting. This is another one of the analytical tools I found in the program. It's not the only one I found. It's just the one I thought um, was the neatest to show in this presentation today. Um, as it's tracking and recording all of the packets during the time it's analyzing, and I only did it for not even 45 seconds, and there were tons and tons of packets, and it will actually chart out the influxes in packets, and you can see there's lulls and there's downtime and there's spikes, which I thought was very interesting as far as looking at when if you're a network administrator, you can look at um, influxes of traffic, or maybe a denial of service attack. If there's a very large spike in um, packets being sent, that's very out of the ordinary. It can be time stamped, and you can see where and when these things came from, which I thought was very interesting. Um, and how to prevent unwanted packet sniffing. So if you're trying to keep your network safe and you think somebody may want to get into your network and take some of the information, whether it's financial data or government secrets or business secrets or whatever reason, I'd recommend to use encryption methods with all your important data. Because of the way packets are set up, they're bundled in bundled data. So you can encrypt them very easy, and then you can send the key to the recipient, and they can receive the packet as normal. But it helps to prevent the packet from being intercepted mid-transit and being picked up by someone that you don't want to know the information. Encryption methods now are very hard to crack. assuming you're staying up to date and there's no collisions found. It's very good at keeping the important data that you don't want someone to know out of people's hands. Um, Another way, well, and it could be in conjunction with um, the data is with encryption is to only provide your information over secured networks. If somebody that isn't authorized to access your network isn't able to, they cannot get to the data on the system, and it keeps your important information safe. Um, People can be trained uh, through security protocols to try to keep everything safe. Secure environments are only as safe as their weakest link, though. So this isn't a smart way to have as an only line of defense. It's just helpful to um, add on to any other security methods you may have. Um, and then using network monitoring software like Wireshark to see where your packets are going and um, what is being done with them to try to track what's going on in your network. It's also maybe a good idea if it's a very secure system to have an air gap so that outside sources cannot access your network without physically attaching themselves to it. If you have an air gap network, there are no connections to the outside world outside of your walls, um, and it makes any sort of intrusion very difficult because the person would actually have to get inside of your building. Um, all right, and so before we wrap up today, I just want to do a little recap. Um, First of all, we talked about what a packet is and why they exist. Um, the packets are broken up into three parts: the header, the body, and the footer. We also discussed a little bit about different types of packets. We didn't cover all of them, but just touched on a few. Um, I talked about some network topography and different layouts of how a network can be laid out, and most are some sort of combination. Um, I talked about what packet sniffing is, as well as going over network monitoring software, Wireshark specifically, covering some of its features and some pictures that I had taken of me using the software. And we also covered some ways that to try to keep your data safe, among other things, for being intercepted by people that you don't want to have it. Um, Thank you very much for listening, and I hope you have a great day.